Our t-shirts, our jeans, so much of our daily lives, it all depends on one single, pretty thirsty plant, cotton. But as our climate keeps changing, this absolutely vital crop is under threat. So today, we're going to look at how scientists are using what are basically virtual time machines to predict its future, and maybe, just maybe, find a way to save it. Let's dive in. Right off the bat, here's what's at stake. $16 billion. That is the potential hit to Pakistan's economy every single year because of climate change. And that number, it's way more than just money. It's about the livelihoods of millions of people and the stability of the global textile industry that, let's face it, we all rely on.
And that is the crucial question, isn't it? I mean, if you know a storm is coming, you can board up the windows, right? So what if we could do the same thing for agriculture, but decades in advance? Well, that's exactly what a team of scientists set out to figure out. First, let's just set the scene. Cotton is a massive global cash crop. It's the fiber in our clothes, it's a source of income for millions upon millions of people. But here's the catch. It's incredibly sensitive to weather, and that puts it directly on the front lines of a changing climate. So, to figure this out, the researchers focus their virtual magnifying glass on one specific place, the district of Vehari in southern Punjab, Pakistan. Now, this isn't just any random cotton growing area. This place is an absolute agricultural powerhouse. Just to give you an idea of how important this region is, this one area produces more cotton than an entire neighboring province. So yeah, what happens to cotton here sends these huge ripple effects through Pakistan's economy and, believe it or not, the global supply of your clothes.
So how in the world do you see the future? Well, you build a time machine, a virtual one. Scientists use these incredibly powerful computer models to simulate both the climate and how crops would grow in the years 2025 and all the way out to 2050. Okay, so the technical term for this is integrated assessment modeling. But don't let the fancy name fool you. The idea is actually pretty simple. It's not just one model, it's a team of models working together. You have one model that's an expert in predicting future weather, and another one that's an expert in predicting how a specific plant will react to that weather. And here's how they did it. It's basically a two-part process. First, they use a climate model called SimCLIM to generate these super detailed weather forecasts for the future. We're talking temperature, rainfall, the whole shebang. Then, they take all that future weather data and they feed it into a different model, a really specific one called crop grow cotton, to see exactly how the plants would grow day by day under those future conditions. Honestly, the best way to think about it is like a super advanced video game, a simulator for farmers. You can plug in different kinds of seeds, you can try different amounts of fertilizer, and you can throw different climate scenarios at it. And then you just hit play to see what happens 30 years from now. It's pretty amazing. So what did this virtual time machine predict? What did the computer spit out? Well, let's take a look at the climate forecast for southern Punjab in the year 2050. The first, and maybe the clearest, prediction was about heat. It's going to get hotter. This chart here shows the projected rise in the average monthly temperature. And what the models predict is a consistent and pretty significant increase. That means more hot days and fewer cold days all year round. And this slide really highlights the two core challenges. On one hand, you have the temperature increase. That's pretty much a sure thing across all the models. But then you have the other side of the coin, precipitation, rainfall, and that's the real wild card. The models showed it becoming totally erratic. Some months might get way more rain, while others could become much, much drier. It's that unpredictability that makes farming so incredibly difficult. Okay, so we've got a future that's hotter and has way less reliable rainfall. The big question is, how does the cotton itself hold up? This is where the simulation really starts to get interesting. The researchers tested two different types of cotton. In farming, these are called cultivars. They're basically just specific plant varieties that are bred for certain traits. So think of them as the two main characters in our story. First up, you've got the common variety, MNH 886. And then you have the challenger, a contender named FH 142. The goal? To see which one would be more resilient. And here are the results. This chart shows the projected change in how much cotton they could grow under different climate scenarios. Now, the common MNH 886 variety, it struggled. But look at this. The FH 142 cultivar consistently performed better. And when they combined it with a moderate amount of phosphorus fertilizer, it was the clear winner.
It actually managed to hold its own, and in some cases, even slightly increase its yield against the odds.
And you don't have to take my word for it. The study itself confirms this. The researchers concluded, and I'm quoting here, that the FH142 cultivar was the better performer, and that applying a moderate but not too much phosphorus was a key strategy to fight back against the climate threat.
So here's the most important part. This isn't just some interesting academic exercise. What the simulation gives us is a clear, data-driven playbook for how farmers can actually adapt and maybe even thrive in a warmer world.
So what are the key takeaways from this playbook? Well, it really boils down to three things. First, your choice of seed matters a lot. Picking more resilient varieties of cotton like that FH142 is your first line of defense. Second, more is not always better. You have to optimize fertilizer use. And in this case, a moderate level of phosphorus was the sweet spot. And finally, these computer models, they are incredibly powerful tools for planning for the future. Ultimately, this research connects all this complex climate science to something really human. It translates all this abstract data into practical strategies that can protect the livelihoods of millions of farmers and, ensure the stability of the supply chain that puts clothes on our backs. What the study gives us is this powerful glimpse into a future where we don't just react to climate change, we can actually plan for it proactively. So if we can create a data-driven roadmap for cotton in Pakistan, just imagine what other vital crops, what other vulnerable places around the world we could map out next.